Hi, my name is Matthew. I'm in period 4 chemistry, and this is my water project. So, let's talk about water. Water makes up about 70% of our Earth and is basically one of the most vital aspects in our world today almost. We cannot live without water, and yeah. So as we know, water is consisted of hydrogen bonds, London dispersion, and dipole-dipole forces, all three. As we know, hydrogen bonding is the strongest intermolecular force out of the three and is ultimately the hardest to break. So if water were not to have hydrogen bonding and only have dipole-dipole non-dispersion, substances could break through and ultimately mix with it. An example would be oil, and how oil cannot break through water with the hydrogen bonding, causing it to separate from water, and you can see it when you mix the two. But if it were to not have the hydrogen bonding, oil would ultimately mix, breaking through the London dispersion and dipole-dipole forces, and not having that hydrogen bonding backing up.
With oil till it gets to about 3/4 of the way full. Then I am going to place the lid on the jar, and I'm going to make sure that it is really tight. Okay? And then once I have the lid on very tightly, I'm going to shake it to mix the oil with the water. Okay? I'm going to shake it about 30 seconds, and then I'm going to set it down and watch.
Hydrogen bonds, water molecules would move faster, more rapidly, with less input of heat energy, and causing the temperature to increase more for each calorie of heat added. The temperature range between night and day would be extreme. It would almost be out of control, which would make living conditions almost impossible. Right. Moving on to our new topic, surface tension. Different location in the bathroom, kind of fitting for water. Surface tension is described as the resistance to spread out. Higher the IMF, higher the surface tension. The higher IMFs in the liquid, the more molecules stick together. So, surface tension would ultimately decrease because of the fact we no longer have a strong intermolecular force in the form of a hydrogen bond. Water would only be able to dissolve non-polar substances. Now, water's ability to stick itself is called cohesion, while water's ability to stick to other substances is called adhesion. These properties are determined by the surface tension of the water. Because the hydrogen bond keep the molecules farther apart, meaning the objects are less dense than the water, causing them to float, which ultimately leads into density. This simply causes water. Is because water is a polar molecule. You might think surface tension is not such a big deal, but in reality, no surface tension means no intermolecular interactions, which means basically, if there is no surface tension, water will just go everywhere. It would just rise, almost as if this water I just threw on myself wouldn't fall. It could go anywhere if there's no surface tension. Everything would ultimately be an ideal gas. Now, in chemistry, we know that the stronger the IMF, the higher the melting and boiling points are. Now, water is a very small molecule. In general, small molecules have lower melting points and boiling points. But based on its size, water should be a gas under normal conditions. However, because it is polar and can form dipole interactions and has a hydrogen bonding, its melting point is much higher. And so is its boiling point. Now, think of this coffee. Think of it as I'm boiling tea. Now, this tea, with hydrogen bond, the boiling point for this tea would be a lot higher, meaning it would take way longer to boil it than without a hydrogen bond. Now, take out the hydrogen bond, and my tea's already done boiling because it has a low boiling point. So it's already boiling right now. It's already boiling. So now That's just in general terms of melting and boiling points. All right. Now moving on to the density of ice versus liquid water. Most solids are more dense than their liquid state. Molecules start to slow down usually and move closer together, increasing the density. Water is an exception to this process, however. Ice is less dense than water due to hydrogen bonds between the water molecules. This creates almost like a hexagonal kind of snowflake structure with empty space in the middle. Dense water sinks until about 4 degrees Celsius. The water on top gets colder, but it's less dense as hexagons start to form. The water on top eventually freezes though. So this feature allows water to a nutrient cycle. In spring and fall, it allows ice to float on rivers and lakes, which I've seen. Finally, solubility water particles break some intermolecular forces with other water molecules to allow them to spread out almost. And they begin to form new ones with sugar molecules dissolving as new intermolecular forces. This solvent carries off the solute. Solvent being the thing that's dissolving something, and the solute being the thing that's getting dissolved. This is called dissolving. Molecules which are capable of hydrogen bonds have hydrogen atoms which are covalently bonded to highly electronegative elements, O, N, or F. The presence of hydrogen bonding between molecules of a substance indicates the molecules are polar. This means that molecules will be soluble in polar solvents such as water. That is why we dissolve most things in water. If the energy needed to break old intermolecular forces is greater than the energy released when new ones are found, this process will not occur. Now, being polar gives water its ability to dissolve many things easily. If water wasn't polar, it could not dissolve other substances and would not be able to sustain life on Earth as we know. We wouldn't have these fertile soil environments. We would have really rocky plains, no plants, as there'd be no water to grow them. And but without water behaving as it does on Earth right now, we would not even be alive today.